1.3 looks at something called geometric sequences. So I have two sequences on the board here. And first of all, we attack these and we're going to think arithmetic. We're going to think, okay, what do you keep adding? What's the common difference? Well, it looks like here to go to 36 to 18, we're going to subtract 18. But then to go from 18 to 9, we subtract 9. So we have to throw out arithmetic. This is not arithmetic. But some of you will look at this sequence right away and see that we are timesing by 1/2. Okay, and so we call the common ratio between the two to be r. And to find r, we go just like arithmetic, we go this term and we divide by that term. So 18 over 36, well, that simplifies to 1/2. Is that the same as 9 over 18? Also equals 1/2. So we have a common ratio. Okay? So again, we take a term and we look at the term before it. Let's look at this one. 4, 12, 36. Well, 12 divided by 4 is 3, and 36 divided by 12 is also 3. So its common ratio is 3. So the next term would be 36 times 3, which is going to be 90 plus 18, probably 108. Okay? In your textbook, you have your key ideas. A geometric sequence is a sequence in which the ratio between consecutive terms is constant. You multiply the same value or variable with each term to create the next term. The common ratio is called r. It's the constant to which each term is multiplied. To determine, we take any two consecutive, two in a row terms and divide the second term by the first term. So r, the ratio is equal to the nth term divided by the term before it. In other words, term 2 over term 1, term 3 over term 2. If I had term 47 to find the ratio, I'd have to divide it by term 46, one less. Okay? Terms of a sequence, again, term 1 is term 1, term 2 is term 1 times r, term 3 is term 1 times the rate twice. So remember when we had 4, 12, 36. So to get term 3, we just take term 1, 4, we times it by its rate once, twice. So look, to find the fourth term, we have to times by the rate 3 times. So to find the nth term, we times term 1 by the rate 1 less than n times. So this is our major formula we're going to use. Tn equals term 1. And maybe you guys can't see that on the screen. I'll write it here just so you see it, but it's in your workbook. Term n is equal to the first term times the rate to the power of n minus 1. Okay? The general term, that's also called the general term, where T1 is the first term, n is the number of terms, r is the ratio, and Tn is the general term. Okay, so let's try a couple examples here. First of all, Andrew and David organize a tree planting challenge. They have people plant a tree and then sign up 3 more people to join the challenge. Andrew and David are the first to join the challenge, each planting 1 tree and signing up 3 more people. State the value of T1, so what's the first term? R for the G and R, so the ratio for the sequence that represents, then state the sequence. The initial planters are Andrew and David, so T1 equals 2. Since they each sign up 3 other people, T2, so first of all there's the 2 of them, then they each sign up 3, so 3 from Andrew, 3 from David, for a total of 6. So to find the ratio, so far we have 2, then 6. To find the ratio, we have to go 6 divided by 2. 6 divided by 2, which is going to be 3. So term 1 is 2, term 2 is 6. Then we times by 3 again, we get 18. Times by 3 again, I need to get my calculator. 18 times 3, well that would be like 30 plus 24, just 54. And is 54 times 3 162? Let's see. Times 3 is 162. Good. Okay. So there's the starting of this sequence. Determine the general term that relates to the number of trees planted to the number of people who sign up for the challenge. So substitute term 1 equals 2 and our rate is to 3. Oops. Our rate is 3 into the formula. Why is it incorrect to write the term as 6 to the n minus 1? Oh, let's see. First of all, we got to do this, then we'll answer that question. So the rate was 3. The general term of the sequence is 2 times 3 to the power of n minus 1. Okay. The reason you cannot write it as 6 to the n minus 1, let's try this. So if I have 4 times 5 squared, okay? So 5 squared is 25. 4 times 25 is 100. Okay, now what if we just said, is this the same as 20? Because 4 times 5 is 20. 20 squared? I don't even know what 20 squared is. Let's look. Oh, where did my I lost my calculator. 20 squared. I think it's going to be pretty big. 20 times 20 is 20 squared. Well, that's 400. Is 400 the same as 100? No. Order of operations. You do exponents before you do multiplication. That is why we cannot multiply these two together, because the exponents have to be done first, and because there's a variable in there, we cannot simplify it until we do those exponents. Okay, let's check if this general term is correct. So what this means is that to find the fifth term, we would take 2 times 3 to the 5 minus 1. Okay, so we go 2 times 3 to the power of 4. So we'd take our calculator and say 3 to the power of 4. Or if we didn't want to use a calculator, we could go 3 times 3 is 9, times 3 is 27, times 3 is going to be 81. So 2 times 81, oops. Okay, 2 times 81, that's 162. So the fifth term is 162, and we already saw that that was true. So we can always check our work whenever we do a general form to make sure that it works. Okay? Let's try another question. Determine a particular term. A company stores 5 kilograms of a radioactive material. After 1 year, 92% of it remains. How much radioactive material will be left after 10 years? State your answer to the nearest tenth. In radioactivity, we're going to see, we see it in chemistry, you won't see it this year, but we also see it in physics. So radioactivity takes, it's like, okay, 92% is left, and then the next year 92% of that, then 92% of that. So it's like a geometric series. So term 1 is 5, the rate is 0.92, and n is 10. So what I'm solving for is, I'm solving for what term 10 will be. Okay, so I'm just putting into my formula, and remember my formula is Tn is equal to, this is term 1, and this is rate to the n minus 1. Okay, and if I forget that, it's back on my key ideas. Tn equals T1 rate to the n minus 1. Now I'm just subbing in the values that they gave me. N is 10 because it's 10 years. Okay, term 1 is 5 because we started with 5 kilograms. The rate is 0.92 because 92%. And the reason we do 0.92 instead of 92 is because, think about it, we're getting less and less radioactive material. We want to convert the percentage into a decimal. Okay, 10 minus 1 is 9, and then we're going to put 0.92. We're going to carry that. Okay, how we enter this into our calculator is important. Okay, we either have to use a bunch of brackets or do order of operations. Okay, so some people's calculators, you could just put 5 bracket 0.92 bracket to the power of 9, and it'll come out with the correct answer. So take a second to see if your calculator does that. If not, you're going to have to do exponents first. So 0.92 to the power of 9 get an answer, and then times that by 5. And we should get 2.3, oops, what was that? 2.36. 2.36. After 10 years, approximately 2.36 kilograms of radioactive material remains. Okay, so that's all the examples I'll do. There's still 2 more working examples that you can get started when you come to class, or we can do them together if you want. Just remember that now the sequence has a common ratio, where you're multiplying by a common term. And a common term could be a fraction, like the example we saw. Even though this is getting smaller, our common ratio, we keep multiplying by 1/2. Okay, so don't get confused and say the common ratio here is 2, because it's not. The common ratio is 1/2. It's getting smaller.